Awesome. I'm Jamie Scott. I'm a recovering security engineer who's spent most of my career at the intersection between security and application security and development. I don't believe that I will ever truly recover from the days of security engineering, especially the forensic side. Nightmare. Sorry, guys. Then the last thing I would add is I'm founding product manager at Endor Labs. So really excited to see how we can start to remove and reduce developer productivity attacks across. And Darren, I'll hot warm you with Darren was our first sales engineer, a developer at heart, one of the best hires I think we've made in a long time. And Darren, I'll let you kick yourself off.
Oh, that's very sweet of you, Jamie. Yeah, I have a ridiculously long life as a AppSec practitioner. I've been doing this for almost 20 years now. Built programs. I've run programs just like you have, Jamie. I've also worked as a security researcher for about 8.5 years. So I've seen that side of things. So I've built things, I've implemented things. I've been a vendor, I've been a customer, I've been a developer. I've racked hardware in data centers. So I have kind of an overall view, and I'm a researcher now for Endor Labs. I'm the staff research engineer. And I'm really focused on that intersection of DevSecOps, right? Where does software development and product and application security and the operations and the business of running a software platform kind of intersect?
Right on. Darren, why don't you kick it off a little bit with setting some context for us. Well, actually, let me really quick advance the slide. So in terms of what we're going to be covering today, we have a little bit of a three-part thing. We're going to spend a good chunk of our time talking about why remediation efforts are painful and not captured here explicitly, but therefore, because they're painful, they may not happen, or they may hurt your credibility with your stakeholders. And then we're going to be talking a bit about two capabilities we released earlier in August, Upgrade Impact Analysis and Endor Magic Patches, where we're focused on changing the whole dynamic about remediation and upgrading so that that pain is, if not totally gone, at least a lot better. So Darren, why don't you talk a little bit about, your background with this and why things are the way that they are?
Yeah, this is one of the big pains in AppSec is getting people to fix things, right? I mean, this is ultimately the goal. We can run tools all day long that tell us we have problems, and we get kind of stuck on the hamster wheel of doom, right? As AppSec practitioners, especially, where the tools tell us we have all these problems, and then we have to fight battles with limited developer resources, limited AppSec resources, trying to figure out what's impactful, trying to make sure that those impactful things get addressed. And I'm a huge Star Wars nerd, as you can kind of see by my little nerd display in the background. So I always think of it as kind of like, as AppSec, we're a bit like the rebels, right? With this small ragtag band that seems to be fighting a hopeless fight against this empire of software development and all the things that go wrong and all the bureaucracy and all of that things and impossible weapons pointed at us all day long. And, we're just this little scrappy band of upstart that never has enough funding, and, our flying fighters that are held together with duct tape and chewing gum. And it really does feel that way sometimes. And I think a lot of that has to do with the fact that we as an industry have so focused on identifying risk, which is, of course, important, right? You have to know what your problems are. And we haven't spent nearly as much time on what do we do now, especially when it comes to things where, just upgrade is the solution, because we know from our experience, even upgrading software, right? Like on your local machine, sometimes it breaks everything. And developers have that problem in spades. Like most of the time, it's fine. They just make a change and it upgrades the package and we're all happy. But it happens just often enough that they upgrade something, or they go to fix a vulnerability of some kind, and it creates a huge knock-on work afterwards. It's a really complex upgrade. It causes everything to break, causes things to not compile. And now developers are going, why am I doing this security stuff? I barely even understand what the problem is. And now you're asking me to do all this work when I could be working on features. I could be working on other stuff. So that's why I'm really excited that Jamie's here to talk about kind of what Endor Labs has been doing to relieve this pain for DevOps teams.
Well said. So we're going to kind of start at the beginning of what Darren was just talking about in terms of the vulnerability management process. And this is going to be review for a lot of people here, but I think it's worth talking through the three phases so that we can kind of align on where the problems are. And so what we generally see is, identify, prioritize, address. Those are the three big bucket stages. And you have different goals and different problems at each stage. And so where a lot of people start, and it can be because they had no SCA tool or because their SCA tool maybe it would have had some reliability issues. They start with trying to get visibility. What are all the potential dependency risks that are out there? I need to find those dependencies. I need to cross-reference them with a risk database. I need to flag not just CVEs and license risks, but potentially leading indicators of risk like an unmaintained library or even malware. But really quickly, the problem that hits people when they get visibility is like, too much visibility. And so the next step in the process is layering on a prioritization framework of some kind. It's assessing relevance, figuring out of all this stuff I found, what actually matters to me. It's about reducing noise. And so this is where often people are looking at filtering by reachability analysis, particularly function level reachability, EPSS. Certainly some people might be using CVSS scoring at this stage. And then potentially also looking at, what might I want to exclude? Do I want to include test dependencies and stuff in prod or just the stuff in prod? Do I want to go chase things right now that don't have a fix available? Not to say you wouldn't fix the things that don't have a patch, but do you have the resources to go develop that in-house, or do you need to go partner with a project? So there's a lot of prioritization. And then once you've prioritized what matters, this is when we get into the address phase. And that's where we're going to spend this session really focusing, is you ultimately have three choices once you've figured out what matters. You can accept the risk, you can remediate the risk, or you can mitigate the risk. And to kind of simplify all three of those, for those of you who might not be in AppSec roles already, accepting risk really means do nothing. And so an example of that would be if you have really good prioritization filters and capabilities, you might be able to say, is something that's reachable, but it's a really low severity and it has an EPSS probability. So probability of exploit is less than 0.5%. You might say, you know what, even though it's reachable, it's really unlikely that it's going to harm us if it does get exploited because it's this low severity. And the probability that it gets exploited at all is really, really low. So we might say, you know what, we're going to accept that risk. The other two options, remediating and mitigating, I really like the analogy of knee surgery versus a knee brace. So remediating with the knee surgery is when you're going to be upgrading the dependency. Often it's upgrading, sometimes it's downgrading to the closest non-vulnerable version. Or the knee brace, the mitigation is you're going to find a patch perhaps that fixes the security problem without changing versions. And this all still sounds more simple than it is. And so what we're going to be emphasizing here is this remediate and mitigate section is where most people get stuck. And Jamie, I'm going to hand it over to you to sort of talk through why we get stuck there and what we can do about it.
Yeah, of course. So one of the things that I always found when I was working with teams to address issues is that there was inherent fear bias. And that's because this is a human problem. No one wants to ship a change on a Friday night. God, we just did that for one of our releases, and we shipped it Friday morning, and by Friday afternoon we were shipping a new one, and it was our release engineer's birthday, and that poor man, we gave him the best birthday gift around. But the reality is that there is fear bias associated with updates, because, well, roughly 70% of updates are just as simple as bumping a version. We tend to trivialize them. And those 30 to 20% of issues that actually require significant thought means that we as an industry are afraid to ship things because no one wants to be responsible for bringing down production. But at the end of the day, we all know you're not a senior dev until you've done it a few times. Now, the fear bias is the first thing because you know it might cause issues, and you can either just ship it and pray, or you can do your due diligence. The other is tool bias. At the end of the day, we as an organization or as an industry don't have visibility into what we are thinking, what impact something will have. And impact isn't necessarily just the reduction of risk. And this is what the security industry generally focuses on. The reality is that the CIA triad is what every security engineer is taught. CIA triad is confidentiality, integrity, and availability. And we don't focus enough on availability outside of the context of business continuity. And the reality is that if we ask for something to be fixed, we may be making a trade-off with availability as a result if we just ship it. And because of that, I mean, no SCA tool is going to tell you, here's your tool test coverage for this. You're safe because you have 100% test coverage for this update. And because the reality is that most organizations live in the gray, where even best-in-class software organizations have 70% test coverage, and most of our real-world people are living in the world of 30 to 50% test coverage, we don't have the right visibility to know that we're making informed risk management decisions based on return on investment rather than reduction of risk, which is what most people do genuinely understand today. So what I want to do is shift that conversation. Jen, next slide. And talk about what are the pain points of actually fixing things. Because if we're going to accelerate risk remediation as an industry, you know, we have a couple real choices to improve outcomes. You can either help focus your team's attention more, or you can help them make more informed risk management decisions based on return on investment. And the number one pain point of making more informed risk management decisions based on return on investment is that nobody actually understands the level of investment. They understand the return, which is risk reduction. And updates introduce hidden risks. And most organizations, until they actually introduce that risk, cut a JIRA ticket, have a dependable alert, and they merge that, or try to merge it and see if their test passes, don't understand if there's breaking changes or potential software regressions, and the software regressions are usually the most fearful. Because perfect testing is a fallacy in industry, what happens? Someone submits a PR with a version change because a version update was suggested, the security team prioritized a JIRA ticket, or a dependable alert came. Pipeline tests fail with this upgrade. And now a developer has to go figure it out. They submitted some code changes, refactor maybe, pipeline test run again, test fails, let's figure it out. And this is a cycle that burns time and takes people away from actually understanding how to deliver new features, bug fixes, tech debt reduction. These are the priorities of devs. And at the end of the day, while developers genuinely do care about security, no one says I'm going to ship insecure code for fun, nearly all vulnerability updates contain at least one potentially breaking change. And when I say potentially, what I really mean is, hey, there's an opportunity to actually break your application. But what actually matters is it going to break in the context of my application, which is a significantly reduced number. So because of this potential, and the unintended consequences aren't necessarily understood. So what is the next pain point?
Sorry, I missed showing this one. So we just pulled these from social media, and maybe some of these sound really familiar to those of you who have lived this world. there's no shortage of complaints about upgrading and breaking changes and fear of crashing an app if you end up on, LinkedIn or Reddit or Twitter, X, whatever you want to call it. Anything you want to add here before we talk about the second pain point, Jamie?
I do want to quickly address one of Anthony Harrison's concerns, where he says contracts are often an issue. Fix all high and critical within X days without recognition of consequences or countermeasures. And you know what? I think that is an industry imperative. I've seen those contracts before. I've reviewed them. I've always tried to disqualify them out. But at the end of the day, we all know that we're never going to get that from all of our big customers. And there's a lot of contractual flow downs that mandate this. And at the end of the day, the important qualifier is fix all in high and critical risk versus all high and critical vulnerabilities. And we even saw PCI recently update its language to say fix risk. And the important thing is really, how do we qualify risk? Is it used in the application? And is the risk reduction necessarily a risk in terms of my application versus and that's why reachability becomes important, because you can really accelerate fixing things even if you have to fix all highs and criticals, but you need to understand and get visibility into breaking changes. So Anthony, I wanted to address that really quick. Beyond that, I would just say devs understand breaking changes loud and clear. What's the next pain point? Foundational packages. The number of our customers who come to me and say, I have a months to years long project of updating Spring 5 to Spring 6 in order to address large portions of my actual risk is astronomical. If you're one of those customers listening to this, know that you are not alone. I hear this every day. And refactoring code is hard. If you're going to update from Spring 5 to Spring 6, well, there's portions of that where we just looked at one fix and it was literally removing 70 Java files. And you have to refactor your code to address this. So like update Spring, that's a trap. Like if you hear that and you know Spring, you're already crying. And if you don't necessarily know, you don't necessarily have that visibility to understand it's a trap. 82% of our customer projects are using the Spring 5 series on the version from 2020. All of them that I have talked to in the recent future are on a long journey to upgrade to Spring 6 across their organization. Foundational packages, ones like TensorFlow, ones like Django in Python, ones like Spring in Java, these are incredibly difficult because they are foundational to what they do. And if you have a breaking change, that doesn't necessarily mean refactor this small thing. It can mean I have to initiate a project to do this, and this will not take hours. This may take days to weeks to months to a year-long project across my organization. Next pain point. So what do teams need in order to actually fix these? They need an AppSec tool that can help them decide what to remediate and what to mitigate in what order. They need to frame vulnerability management in terms of the actions that they ask their developers to take instead of fixing individual vulnerabilities. If you send a dev team a list of 149 high and critical vulnerabilities and say, triage these and fix them all, like that's going to create friction. What we should be doing is saying, send them these 3 updates. We're going to fix 90 of these 149 vulnerabilities. I want you to do this because this is going to have an outsized impact. And ultimately, AppSec teams want to address risk immediately, but they don't necessarily have the visibility or the contextual understanding of an application to do that effectively. AppSec is one of the hardest portions of the security industry because we are accountable for risk reduction, but we are not responsible for large portions of it. There's very few AppSec practitioners in industry where the AppSec teams are fixing things. And even when they go and fix things, they don't have the context to deal with the fallout if they need it. You need a partner and you need a dev stakeholder in order to be successful as an AppSec program.
So, question for you, Jamie, is something I got asked a lot as an AppSec leader is why should this be Dev's problem in the first place? Why can't AppSec just do it?
And look, I think there's two real problems there. First is a skill gap. And we talk about this all the time in industry today. Anyone in AppSec is familiar with this. There's entry-level jobs that require a CISP because the skill gap is so wide and sweeping across our industry. And the reality is that, like, I'm a CISP. When I got that, there was not a single thing that ever taught me how to build software. And so the CISP is our quote-unquote advanced specialization certification. But, that's a mile wide and an inch deep. And I like to call it my badge of shame. Like, I love it. I think it advances our industry, but it should not qualify me as an expert by any means. It should qualify me as advanced. The second thing is, why should AppSec fix this? Well, I think it's nice that they should be able to submit a pull request, but outside of the context of the skill gap, it's the context gap. Like, if the app breaks, AppSec, well, I would love to say they know the business. They're not going to be the one who gets called on an on-call. And PagerDuty is not going to ring them at 3 a.m. and say, we have an outage because of this fix. PagerDuty is going to ring that dev. And if the dev's on the hook and not the AppSec person, well, they probably want to be the one to actually make the change and actually know and thoroughly test it. And because we don't have context into application-specific functionality, it's very difficult for us and candidly rarely scalable without a very mature security champions program.
Yeah, I mentioned in chat that I've seen some AppSec programs try to do this, and finding the AppSec resources that you need that have the development background that can stay ramped up on the applications so they can actually make the changes. It's very, very expensive. I've seen it succeed twice, and they were both huge organizations with huge product security budgets because they were security products, right? They could get away with it. Nobody else has been able to make that work because the budget just isn't there.
Yeah, exactly. And I see a comment here from Anthony about one of the problems is the number of false positives. Vulnerability scanners that are high level, using package X when it really needs to be, I'm using the vulnerable function Y in package X. So that's really getting down to reachability, right?
Yeah. It's probably a great segue at this point.
Yeah. Okay. So let me bring the slides up bigger again. And so we, again, kind of refresh of where we started. We got visibility. We managed our plethora of visibility by assessing relevance. And then the thing that we run into next, and it's kind of an always problem, but in particularly it's a problem here, is a time problem. And so what the team really needs is some way to assess ROI of the upgrades that are on your table to say, which ones should I do right away, or should we prioritize right away, and which ones will take longer? And so this looks like prioritizing by effort and impact. It looks like making a choice to remediate that stuff that's easy. And then we're going to talk about fixing stuff that's hard. And so, Jamie, this is probably a good time for me to unshare my screen and you can pop in. Let me find the right button. Confirm. There we go. It's yours.
Cool. Let me pray this works. I apologize for a few minutes of inception.
Nope, it's there.
So, Anthony, at the end of the day, I think you're absolutely right. And I want to show you what this looks like in practice. This is an intentionally vulnerable app. This is something that is built off of an OWASP foundation. It's our contribution ring to the OWASP Foundation's vulnerable SEA. So inherently, it's going to have a crap load of vulnerable SEA, reachable vulnerabilities. But I want to do what any normal security person does. I'm going to filter on high and critical. And I have 112 findings. Well, that's cool. But at the end of the day, I want to know if it's actionable. Don't care about test software. This isn't malware. This is vulnerability management. And so now I've got 110. That's done basically nothing for me. It's all actionable. Again, this is a curated vulnerable app. Now I'm going to click here and I can say, okay, this Jackson data bind vulnerability is actually reachable in the context of my code. I can see that because the reachable function is there. I click more details, and what I can see here is that if I go to this call path, the main controller function calls Spring Boot that traverses several software dependencies all the way to Jackson data bind. And this calls the subtype of validator validate subtype function. And this is one of the vulnerable functions associated with this CVE, CVE 2020-9548. So this is the first thing that says this merits me focusing my attention on this thing. And because I should focus my attention on it, I know that I can deal with what I would argue is a debate between, is this a false positive or is this a false positive risk? This is a real legitimate vulnerability, but in terms of risk, this is a false positive. This is not a false positive because I actually use this. So this is how you first start scaling AppSec programs. You focus your team's attention on what matters. And then the question becomes, oh, well, how do I update this? And here I've got the vulnerable application here. And I want to start by saying I have 149 findings. This is going to take care of 38 of them right away. And we can't use, as a security industry, the proxy for risk as the finding. We should focus our devs team's attention on the actions that they should take. And here I can see a few things. I can see the version update options that I have, what impact they have in terms of the fixed findings. So this is your return on investment. And I know that the thing that's going to have the single highest return also has high remediation risk. What does that actually mean? Well, if I want to fix 3 critical and 35 highs in this app, I can see, okay, this is worth the return. It's got these vulnerabilities are reachable in the context of the app, but it's got a breaking change associated with it. The class name ID resolver function used in deserialization main in my application has been changed. And the visibility level of this has changed from public to protected. And therefore, this function is no longer accessible. The visibility is protected now, and therefore this is a breaking change because I can no longer access it. I have an access issue. And what is...
If I can interrupt you for a second, Jamie, like I know this kind of gets down in the weeds relatively quickly because it's really cool technically, but I think just from a level up, from an AppSec practitioner standpoint, what I have in front of me is 3 things that I'm seeing. And correct me if I'm wrong. One is I now have like data from my tool that tells me what I can expect of my developers. If I ask them to fix something that has high risk, I know they probably need a longer SLA for it. We probably need to have a conversation. If I know it's low risk, I can tell them, look, this is probably not going to be a big deal, and I can help them get past their fear of doing the upgrade. Is that fair?
Yeah, absolutely. I would put it this way. When I was a security engineer, what I found was that my credibility was constantly being questioned. And in a world where we're accountable for risk reduction, but not necessarily responsible for it, credibility is our sole currency. We can push the envelope with actual business risk, but our currency day to day is our credibility. And when we say update to 2.12.7.1, this is trivial. Our credibility comes into question.
Ask away, Jamie.
Sorry, Siri got in the way. So our credibility comes into question. If we as AppSec want to have a seat at the table and actually have a real risk management conversation so that with the business to make informed decisions, risk also means coming at it from their perspective. We need to say, what is the level of investment this will take? Well, this is not a trivial thing. I can better set expectations in that risk management conversation. And I can say, okay, this is going to require some code refactoring, but we have a choice here. We can either accept 3 highs and go to 2.9.10.8, or I can get those 3 highs and go through the code refactoring conversation. This is how you set better expectations, and setting better expectations helps you establish credibility, which is the currency that you spend.
I'm really
Darren,
liking too that I see that we flagged the one that has like high value and low risk as recommended. That's really helpful to me because like as an AppSec person, even with a development background, I don't know this app. And so like it's always hard for me to know like what is the low hanging fruit really? Like I can look at risk stats all day long, but like what is the thing that's going to be the most bang for my buck is something I usually have to spend a lot of time talking with people who are familiar with the app to get to. This gets me halfway there, right? Shortens those conversations a lot.
yeah, absolutely. Yeah, I think the most important thing is how we can, one, accelerate how risk reduction occurs, but two, how we can do that as a genuine business partner. And I'll put it this way. Every CISO, their top strategic imperative is to build trust, empower teams. Ultimately, security needs to be a business enabler. How do you become a business enabler? Well, you sit there and you say, hey, you can do it fast or you can do it hard. We're going to have these expectations up front so that we can make informed risk management decisions. How the tax that we put on our teams is not having that visibility in order to have those informed decisions easily. So if we want to be a business enabler, we have to establish trust. We have to set better expectations. This is how we do that. But at the end of the day, we have one ultimate goal, and it's risk reduction. This is what we're accountable for. We're trying to protect our business, and part of that means the business needs to operate. The other part means we need to reduce vulnerabilities. So what happens if this is hard? Well, Endor Labs provides a magic patch for you. And what is a magic patch? Endor Labs has backported the actual vulnerability fixes to an older version so that you don't have to spend the time addressing incompatibility issues. What we've done here is we've provided a completely transparent solution to our customers so that they can fix things fast, even if it's hard. How do we do that? I've got 3 critical vulnerabilities here that would be addressed using effectively the same version. If I were to update to version 2.12.7.1, which is something I actually have a dependabot update for, what's that going to do? That's going to introduce literally 100,000 lines of code change. If I want to just fix these critical vulnerabilities, all I need are 7. This reduces the amount of change and the risk associated with it. And if I change from version 2.9.10.3 to 2.9.10.3 Endor latest, which is the latest version patch that we've backported these fixes for, I change 7 lines of code. These are the exact things to change. And we do this in a transparent way where our build logs, our test processing logs, our deploy logs, and reproducible builds are available to you. This way you can establish trust, but you also have that option to mitigate the risk when things are hard so that you can achieve your outcomes without necessarily having to worry about the time and opportunity cost that you're accepting by achieving them. Darren, want to pause there? Anything you'd add?
I think the big thing that I'm seeing here is this idea that this works like a tire patch, right? So that we have this mentality often in AppSec that we have to like fix the problem, and mitigation is hard to do because it has to be some kind of external control, and it's so much work to figure out if that external control is really going to protect us, right? But this is more along the lines of like I've got the flat tire. Instead of having to change the tire on the roadside, I can put a patch in place. Maybe that even is good for the life of the tire, right? Depending on the situation. So I might have a problem that I can solve with very low ask from my developers. And the less that I ask of them to do, the more they get done for me and the more risk that they're going to agree to help me boil down.
Absolutely. I would say the best thing that I think that would have changed my life when I was a security engineer is if I, 1, knew if something was hard, and 2, had an option to fix it. This is kind of the golden goose egg of remediation and everything that I always wanted when I was in AppSec. I think the most important thing is how do you give teams confidence to fix? If you're going to give teams confidence, you set the right expectations by telling them this is a breaking change. What do we do here? Well, I'll show you another example in MetaGPT. In MetaGPT, LangChain community has high remediation risk as everything. But it's also the one thing that has an outsized impact when it comes to risk reduction. And I've got several breaking changes here. Some functions were moved. Other capabilities were added to existing functions. And you saw that the function actually changed from public to protected in my Java example. But how do you set that expectation? You understand when things are hard, and not only that, but why they're hard, so that not only can you say, I know it's going to be hard, I'm going to set the right expectations, but you can give them the confidence to fix by actually not having them have to go through, build error, and figure it out. You give them that information up front so that they can triage more effectively. And this is how you give devs the confidence to fix. Pause there. Questions from Jen, Darren, audience?
Yeah, there was one question from Anthony about where we're starting support with this. And I know the short answer, but I didn't know if you wanted to maybe expound on that a little bit.
Support with what specifically?
Ecosystems for magic patching.
Yep. So in short, what we're doing is we're starting with Java. Java is something, at the end of the day, Java is one of the most used languages across industry. Generally, JavaScript, Java compete. Java is one of the things that we see most in our customer bid and our early partners trying to solve these problems. So we're starting with Java. We are expanding there. Anthony, if you'd love to partner with us, I would love to ensure that this is a reality for you. In terms of breaking change identification, showed you Java, Python, help set those expectations. We're expanding rapidly from there.
All right, it's probably a good time for us to transition more formally into Q&A. Did you show everything you wanted to show, Jamie?
Yep.
All right. So as a reminder, we have the questions tab here in the UI. So you can use questions or just drop us thoughts in the chat. Where do you want to start, Jamie and Darren? What do you see as the big meaty questions that are kind of on your mind, what you're hearing most from people you're talking to in the community?
I mean, I think the thing that people respond to the most when I've kind of explained this approach to things, people, they see the benefits right away, and then their first question is like, okay, how can I trust you guys to do this analysis accurately? How can I trust you guys to deliver me code that's going to go into my supply chain?
Yeah, Jamie, why don't you tackle that?
Yeah, and I would put it this way. We have an implicit trust when it comes to software reuse. We do that to innovate quickly, but at the end of the day, open source software is a $7 trillion industry of innovation that we can tap, and it's become irresponsible for us not to. So how do you trust open source is the first question. Well, you do due diligence. What we're doing is we're backporting the fixes that already happened in upstream and moving them down. It's the same level of trust barrier that you have today. That being said, we do this in a completely transparent way so that you can fully audit this. We can show you what we test, how we build, how we deploy, and ultimately the exact fixes that we've made, and if those were made by us or the open source community. So we think that transparency is everything in security. And so that is our top priority when it comes to building trust.
Yeah, so kind of aligned to that, we have a question here about how does Magic Patches work? I think there's probably a few different ways we could interpret that in terms of functionally under the hood, how does it work? Or what is the experience like when you decide you're going to use a Magic Patch? So kind of decide where you want to start with that, Jamie.
Azan, if you're still there, can you tell me if you want the nerdy answer or the business answer? Because I can tell you both. But I'll give you the business answer. Tell me if you want the nerdy answer. How Magic Patches work. Nerdy? Okay.
Nerdy it is.
So
buckle up.
Give me one sec. I'll share my screen again. All right, let's take that version of Jackson data bind. What happens here? I've got 127 file changes, 800,000 additions, 20,000 deletions. Like, nobody's going to actually audit this. And how does this change? Well, your workflow, well, I've got this dependent alert, right? I already said there was a breaking change here, so this broke my build. This breaking change was introduced in version 2.10.0. What's a magic patch look like? This is a fairly simple thing. It's a backported version of the patch. All you have to do in order to use this is, one, connect your Artifactory to the Endor Labs patch factory. That is as simple as creating an API key for us in Endor Labs, putting that in an Artifactory, configuring a virtual repository there, or adding it to an existing virtual repository that you use. Way to do this in open source is just to add the repository directly to your POM XML and Maven. Reality is that in most organizations, they're just going to have this done for them already. This is already part of your Artifactory Nexus config. Then what happens is you have two options. One is I can use...
Sorry, quick interrupt. Sounds asking if this is a custom version of the library.
Yes, this is a custom version of the library. That being, Endor latest is added to the exact same version number in order to use it. We do have the option of automatically downloading the latest patch version every time, and that would just involve changing your Artifactory config in order to actually have that be the top priority in your virtual repository. That said, all it is connect to a different package repository that Endor Labs provides patches in for you, so that you can use them to get confidence that you've fixed the thing. And then when we perform an SCA scan on you, those will be visible to you that your bill of materials is using the artifact version from Endor Labs, and those findings that have been fixed will no longer be reflected. If we have not fixed a finding, they will be.
And then a follow-on question, how will it get updated when the open source library is updated?
Yeah, I want to take this one a little bit because this is a workflow thing that people have asked a lot. And basically the thing is, people have a version specified in, like in this case, in a POM XML, in a manifest somewhere saying, this is the version I want to use. These places where we're providing magic patches, there's already an updated version of the open source library that has the fix in it. It just came with a bunch of other changes that are hurting you. So it's really a developer decision of, when do I want to upgrade? Do I want to take the pain of upgrading the library all the way up to current, or where it's kind of officially fixed, or do I want to put this band-aid on it? And the idea is then that we have patches for every version in between where we are today and where the open source library has the official fix. So the developer still has a lot of control over where they're using and what level of upgrade they want to go to while maintaining that patch. And then if they want to flip over to using the official line again, it's just another change to the manifest, just like if they had decided to upgrade through normal pathways. So this is the workflow that developers are used to doing and making upgrade decisions. We've just given them a side forked path to go down, and they can maintain transparency across that whole thing.
Yep, and Izan, that's absolutely correct. It's a custom version as a stopgap, but eventually move back to the open source version. Like, at the end of the day, the one thing that I want to say is, like, this is a mitigation. Your remediation is actually go to latest, but no one wants to sit there and refactor code while they with risk sitting there. This is your stopgap. This is the, Jen, if you have it's knee surgery versus a brace. This is the brace where your risk is removed, but at the end of the day, you still want to use the version, and no license violations with the custom version.
Yeah, people ask about open source licensing a lot with this. These patches are available. They're released under the same terms as the original project. The project is basically saying, we don't want to backport, so we're saying, okay, we're just providing you a fork under the exact same license terms. So if you need access to the source code, let's say it's GPL, right? You need access to the source code so that you can publish it too. We give you that. It's all there and in the open. And yes, we'll stop reporting the vulnerabilities against custom version because we know it's fixed.
While Jamie's typing away, this is kind of a rough workflow of what this can look like. It's that decision point of, do I want to remediate? Do I want to mitigate? You have full visibility into the risks that come with remediating, so you can make the best decision based on the payoff. And so in this example that we have, we discover 14 high findings for one particular library. And we've determined, well, you can do a low effort fix that is unlikely to break anything. It's only going to fix half of those high findings. The high effort, or the 100% finding fix, could be a high effort here. And, maybe you're in a situation with the FedRAMP SLA where you don't have the ability to get to this 100% fixed 14 findings during that SLA period. And so you say, okay, I'm going to go ahead and I'm going to go the mitigation route. I'm going to apply a patch so that I can meet that SLA right now. And then your engineering team will then start to take on the work of what will it take to move to this version 5.1.8.
Right. So I want to click on that a little bit. When you have compliance things that give you an SLA, this lets you kind of destroy the SLA, because the SLA is to close the vulnerability, and the magic patch does that, and we can prove it. We test these things internally to make sure that any available exploits don't work and all those things, to make sure that our backport is good. So you close the vulnerability, your compliance SLA closes as well. You did your job. You're just going to go forward as an organization and have a conversation about, okay, now that the vulnerability is closed, what do we want to do with the risk of now we're using this patch version off to the side? We want to have a pathway to get back onto the official line. How do we do that? But the timing is up to you, not up to somebody externally who's saying, this is your most important thing, you have to do it in 30 days.
Yeah, and I think, Anthony, you're asking a smart question about, whether other SCA tools will still report the version as vulnerable. If your customers are scanning your product and they're finding what looks like vulnerabilities using whatever tool they're using, you still could potentially, if it's flagging it, have that problem. But the whole point is, and Jamie, I see you're typing, why don't you just come on and talk about it around why this is something we've addressed?
Yeah, so one of the things that we've already created our own reporting. The issue becomes, does your SCA tool respect those? And the reality is that we're actively exploring how we partner with other SCA tools. And that comes with our customers going to them and saying, hey, let's build support. That being said, you're absolutely correct. And that's a trust barrier that we would love to partner with you on, Anthony.
All right, we have about 10 more minutes. We won't make everyone stay if there's no more questions.
Yeah, and Anthony, I would say if your SCA tool does support like Vex in parts or something to that effect, then we provide Vex that you could import.
And for anyone who's unfamiliar with Vex, it's kind of a companion document to a software bill of materials. If the SBOM is your ingredient list, the Vex is your allergen list. In this case, we can export an SBOM and a Vex, and it's going to show that the vulnerability was taken care of. So that puts you that much more ahead of, rather than having to then, go dig down. Because in an ideal world, nobody is manually triaging any of these, right? So you have a document that can help you have that conversation. And Darren, I see you just put a paragraph. So rather than me reading it, is there anything you want to add out loud about what you just?
Yeah, I mean, basically, it's hard to make a generalization because every SCA tool takes a slightly different approach to how they do this. But in general, when they're looking for that initial, do you have a package and does it have a vulnerability? They're looking at the version. And if our version is 4.12.1 Endor latest, that's different than 4.12.1. So most SCA tools are going to look at it and go, I don't know if that's affected. It doesn't seem to be. It's not in my list. I'm going to report it. In some cases, they'll look at version ranges and go, well, it's between the affected ranges, and they'll report it. And there's first of all, it's really easy to find that because it says Endor latest right on it. And the second thing is like that's a false positive on their end, and that's why we're reaching out to other SCA vendors to, try to develop a standard for if you're going to do this kind of magic patching work, how do we make everybody aware of it so that we have a lower false positive rate? So like it is a real problem, but it's one of those where the problem is based on assumptions that people make. So it really depends on what design assumptions the other SCA tool has about matching work.
And I'm just sharing a couple of resources for things that we've mentioned a little bit more in passing here. If you want to learn more about VEX, learn more about EPSS, we have a couple of items there. I think with that, it's probably a good time to start wrapping up. So reach out directly if you want to talk more about these topics. The three of us are here because we love doing this. So you can find us on LinkedIn or reply to your confirmation email. And with that said, thank you so much for your time, Jamie and Darren. It's always great.
Cheers.
All right. Have a good one, everyone.